Hello everyone, myself I am Divya from Department of Chemistry, working as Assistant Professor in Marri Laxman Reddy Institute of Technology and Management. So in last session we have discussed a topic that is corrosion and how it is affected and types of corrosion. So in today's session we are going to discuss a next topic from the corrosion, that is corrosion control methods, how we are going to control the corrosion and also the surface coating. So under corrosion control methods, we have many types of methods like cathodic protection or protective coatings or designing. In all these methods, now in today's class, we are going to study about cathodic protection. What do you mean by cathodic protection? And by cathodic protection, how we are going to protect the metal from the corrosion. So under cathodic protection, we have two types again, that is sacrificial anodic protection and the other one is impressed voltage. So first of all, what do you mean by cathodic protection? So whenever we take a base metal, so this base metal, when it is in contact with either environmental gases or any conducting medium or the liquid, this base metal will be getting corroded. So now to protect this base metal, if our metal is a cathode, that is protected. If it is an anode, it will be corroded. We know it because under anodic part, oxidation corrosion will take place. That means loss of electrons will be occurring. Next, at cathode, gain of electrons will take place and hence cathode metal will be protected. So now we are going to do a thing is that we are taking a base metal and we are going to make it as a cathode. We are forcibly acting this base metal to act as cathode. When it is acting as cathode, now this cathode will be protected from the corrosion. So how we are going to make this as a cathode means, we are going to connect the anodic metal to this base metal so that the corrosion will occur at this connected metal and this base metal will be protected. That means now it is acting as cathode. So cathodic protection, simply it means we are going to take a base metal and we are forcibly acting this base metal to act as cathode. So see the definition, the method of protecting the base metal forcibly making it to behave like a cathode. Why we have to make it as a cathode? Because if it will be a cathode, then reduction process will take place and here gain of electrons will be occurring. That means this metal will not be getting corroded. Like therefore the corrosion does not occur and it is called as cathodic protection. Now as I said, this cathodic protection is divided into two types, or we have two methods here. One is sacrificial anodic protection and the other one is impressed voltage or impressed current cathodic protection. Okay, the first one under cathodic protection is sacrificial anodic protection. From the heading itself, you can understand that anode is sacrificing itself to protect the cathodic metal. How we are going to see here? In this method, the metal to be protected, metal to be protected means what? It will be of cathode or a base metal. Whatever the metal we want to protect it, that metal we are going to connect it to a more anodic metal, more active metal, or okay, whatever the metal you want to protect, you are going to take a base metal. This is your base metal and you want to protect this base metal. So in order to protect this base metal, you are going to connect this base metal to a more anodic metal. So now in this case, what is happening? This more anodic metal sacrifice and now this will corrode and it will protect the base metal, that is your cathode. This is what happens under sacrificial anodic protection. See here, more anodic metal undergoes corrosion. Whenever we are saying it is an anodic metal, so this anodic metal, which reaction it undergoes? It undergoes the oxidation reaction. That means it will be losing its ions and electrons. So we know that anodic metal will be corroded. So now the base metal is connected to a more active metal, right? Now this more active metal or your anode will sacrifice itself to protect the cathodic metal. How it is going to protect? By supplying the electrons to the base metal. So oxidation means it is losing its electrons, right? Now these electrons are moved to the cathode and hence cathode is protected, making the base metal as a cathode and protecting the base metal. If you observe here, we are going to connect an anode to a base metal. The more anodic metal gets corroded and hence it is called as sacrificial anode. So this method we call it as a sacrificial anodic method. After continuous use of this sacrificial anodes, they are going to be replaced. So if you observe, this is your cathodic metal and this is your anodic metal. So when you are going to connect this anodic metal or more active metal to this your cathode, now the electrons will move from anode to cathode. Hence you can see how this anode is destructed. Okay, the part of the metal is destructed because of moving, like these electrons are moving from anode to cathode. But here if you observe the cathode it is good, it is protected. So here base metals we usually take it like a iron, copper, okay, like brass, and also here we are using anodic metals like more active metals, as I said, like magnesium, zinc and aluminium. So some of the examples of this sacrificial anodic metals or the method is like we are going to protect the buried pipelines, ship hull, and also the water tanks in industries, and also the steel rods, by connecting this to a more anodic metal. This is the sacrificial anodic protection. Now we have the other type of method under cathodic protection, that is impressed current cathodic protection, or we also call it as impressed voltage. That means we are going to have some corrosion current, but to the corrosion current, the opposite current we are going to produce so that the cathode, like the metal can act as cathode. The cathode metal will be protected. Now see, in this method, impressed anodic current is applied in opposite direction. Okay, why we are going to provide it? To nullify the corrosion current. Because of this, it is converting the corroding metal, whatever the metal it is getting corroded, it is getting converted from anode to cathode, which remains unaffected. So when this metal is converting into a cathodic metal, it will be unaffected and corrosion does not take place. So if you observe, metal to be protected is made by cathode, the base metal. Remember, whenever we are saying metal to be protected means base metal. Now this cathode we are going to connect to a negative terminal of DC battery. If you observe, this is our negative terminal. Now to this negative terminal we are going to connect our base metal. Base metal means the metal which we need to protect, or the metal which act as cathode. Okay, this cathodic metal or the base metal we are going to connect to the negative terminal of the DC. Now the electrons supplied by the negative terminal of the DC current will convert. Now because of this electron supply, it is going to convert the corroding metal from anode to cathode, and it prevents the corrosion. We know when it is converted into a cathodic metal, corrosion is prevented. So here we are using as graphite rods, stainless steel or the platinum is used as the inert anode. Whatever the anodic metal we are using here is like we are using steel or graphite. Now this anode, by connecting to the positive terminal, now we have a DC here, the negative terminal is connected to the base metal and the positive terminal is connected to a anode, and here anode we are taking as a graphite or steel or platinum. Now this base metal will be unaffected. Examples we are using like buried tanks, pipelines and the water storage tanks in the marine industry. These are the examples for impressed current voltage. Now we have the second method of protecting the metals under protection of metals from the corrosion, like protective coatings or the surface coatings. That means we are taking a base metal or we are taking any metal. Now if you want to protect that metal, we are going to coat that metal with the another metal so that the corrosion does not take place at our base metal. So it is one of the oldest and common type of method of protection of metal from its surroundings by applying a protective coating. Okay. So if you take a base metal, now I am coating with some protective coating so that corrosion does not take place near the base metal. If your base metal, if it is uncoated, then the environmental gases or the surroundings will affect your metal and it gets corroded. So in order to prevent this type, we are going to coat the metal. Now, corrosion coating is a process of covering a surface or substrate with another substance. As I said, base metal we are going to coat with a protective metal. Like it may be of temporarily or permanently. Like now, this will protect it from the degradation of metal. As a result, its reaction with the environment or the corrosive agents. Now, what do you mean by metallic coating? Okay. Now, we'll see first of all, metallic coatings are produced by conducting one metal on the surface of another metal. Now, we are having a metal like this. So, on this metal, we are going to coat with another metal. This is one metal. Both are metals, okay? So, we are going to protect a metal by coating with the another metal. Now, the metal which is protected, that means this base metal. The metal which is protected, we'll call it as base metal. And the metal which you are coating, the metal which is used as coating is known as coating metal. So now again here we have the two types under metallic coatings. Those are anodic coating and next one is cathodic coating. Depending upon the coating metal, the metallic coatings are of two types. One is anodic coating and the other one is cathodic coating. So we'll see first one is anodic coating. That means we are taking a base metal or the metal which we want to protect. On this base metal, we are going to coat with the more active metals. See, a metal used for the surface coating is more anodic than the base metal or more active metal than the base metal. As I said, we are going to differentiate the metallic coatings into two types based on what? The metal which we coat on the base metal. That means a coating metal. Coating metal. Based on the coating metal, we are having two types. One is anodic and the cathodic. Anodic means what type of metal we are going to coat? That is more active metal. More active metal on the base metal. So for example, these more active metals are like aluminum, cadmium or the zinc on steel surface are anodic because their electrode potentials, why we are selecting these type of metals means their electrode potentials are lower than that of base metal like iron. Base metal here we are using as iron. So when we compare the electrode potentials of this base metals, it will be lower. Therefore, anodic coating protect the underlying base metal sacrificially. This is about the anodic coating. Here what we are using, more active metals we are using to coat the base metal. Now we have other type, that is cathodic coating. Same as anodic coating, here we are taking a base metal and coating the another metal. Now the metal which we are coating, or the coating metal here we use are noble metals. Noble metals. So see, cathodic coatings are obtained by coating a more noble metal. In anodic coating, what we have seen, more active metals, right, or more anodic metal, right? But here we are using a more noble metals, like these metals having a higher electrode potentials. There we are having a less electrode potential, but here we are having a higher electrode potential than the base metal, so that base metal will be protected. Now they protect the base metal as they have higher corrosion resistance than the base metal. These are the definitions of anodic coating and cathodic coating. Now we'll see examples for anodic coating and cathodic coating, each one. So the applications of this metallic coatings are like hot dipping. Okay, it is one of the application for the metallic coating. So first of all, what do you mean by hot dipping? Simply by the word we can say it as a, we are going to take a base metal and dip in the solution so that the impurities are removed and one of the coating metal will be protected on the base metal. So we'll see, this is a method of coating a low melting metal. What? Low melting metal like zinc, lead or tin, aluminium, etc. on the iron or steel or copper, which have the higher melting points. So what they are doing, they are taking a higher melting point base metal and they are going to coat a metal that is having a low melting point. Low melting point. Now, the base metal is dipped in a molten bath. If you have observed here in a picture, you can see a metal is going to dip in a solution. So, that is your molten bath of coating metal. So, this is your base metal and the solution is of having a coating metal. So, what they are doing, they are going to dip the base metal in this solution so that the coating metal will be attached to the base metal to protect the base metal. So widely used hot dipping methods are galvanization and tinning. So these two are very important methods under hot dipping, and now this galvanization will come under anodic coating and the tinning comes under cathodic coating. Cathodic coating. Now we'll see first of all, what do you mean by a galvanization? So galvanization means the process of coating zinc metal on the surface of iron. So if you observe here, your base metal is iron and your coating metal is zinc. So if you observe this type of combination, that means a zinc metal is coated on the iron metal. So to protect the iron, this combination we call it as a galvanization, or this type of coating we call it as a galvanization. So as we are using a zinc, it is a more active metal or the more anodic metal. Now this process or the method will come under your anodic coating. anodic coating. So in this process, what we do is, first iron is cleaned by pickling with a dilute sulfuric acid by some acid, by some acidic solution or by some acids. We are going to pickle the iron or the base metal. Pickling is nothing but we are going to remove the impurities. Simply we are going to dip this base metal or the iron metal in the dilute sulfuric acid so that the impurities will be getting removed. So we are going to maintain a temperature that is 60 to 90 degrees for 15 to 20 minutes. 15 to 20 minutes. So first we are going to take a iron metal. Okay, we are going to dip in the dilute sulfuric solution so that the impurities will be removed, and we are going to maintain a temperature that is 60 to 90 degrees for 15 to 25 minutes. Now, therefore, it removes the scale, rust, other impurities present, and now after removing all these impurities, it is washed well in a water bath and then dried. Now, after this, we are going to again dip in a bath containing a molten zinc. Why we have to dip here? Because now this zinc metal should come and attach, or now this zinc metal should coat on our iron metal. Okay, so simply before imagine this is your iron metal. Now you want to coat this iron metal with the zinc. If this iron metal is having any small impurities, again this iron metal will be getting corroded. Now before to do a protective coating, you have to cleanly remove all these impurities. So to remove these impurities, we are doing acid pickling. That means we are going to dip this base metal in the acidic solution and we are going to remove the impurities. Now the iron metal or the base metal is free from the impurities, now simply you can dip in the molten zinc. So the base metal is the cathode, okay, and the coating metal here we use is zinc, right? It will be acting as your anode, and here base metal is your iron. This is how it will be getting coated. Now, to prevent it from oxide formation, the surface of bath is covered with ammonium chloride flux. Okay, to prevent the oxide formation, why we have to prevent it from the oxide formation? If again oxide layer is formed, the corrosion will take place. So to prevent this type of corrosion, we are going to cover the bath with the ammonium chloride flux. Now the iron sheet is taken out and it is coated with a thin layer of zinc. To remove the excess zinc, it is passed through a pair of hot rollers. So we are going to have two hot rollers like this. So now whatever the iron sheet we have that is covered by a zinc metal, now this sheet is going to pass from the two hot rollers so that the excess of zinc metal will be squeezing out. And now here we are maintaining a temperature like 450 degrees. And next we are going to cool it. If you observe the picture here, first we are going to do a surface preparation. Like this, a bath will be there. You are going to dip your iron metal in these baths, okay, to remove the impurities or to clean all the impurities or the rust on the iron metal. And finally you are going to dip in the molten zinc and also covered by thin layer of zinc, and now it is moved into a hot rollers like this. When it is moved, see, yes, hot rollers, a pair of hot rollers are there like. Now here you are going to pass your metal so that the excess of zinc is removed. And finally you are getting a iron that is covered with the zinc metal, and now you have to cool it. So this is how hot dipping process of galvanization will take place. first surface preparation we do. That means we are going to clean it. So first is caustic cleaning. Salts, everything will be removed, and again we are going to rinse it once. Pickling, as I said, we are going to pickle with what? Dilute sulfuric acid. Now after pickling, it is again we are going to do rinsing. What we are taking flux solution as a molten zinc. Next, we have the applications of galvanization. So it is most widely used to protect the iron from roofing sheets, wires, pipes, nails, bolts, screws, buckets, and also the tubes. But it is not used for the utensils like for preparing or storing of foodstuffs, because when we are pickling with the acids, right now, especially in acidic in nature, this zinc dissolve to form highly toxic. So for this, in case we are not using for the preserving the foods. So next method we have under hot dipping is tinning. So what I said, tinning means we are base metal is there, right? Now the coating metal which we are going to coat is a tin metal. Simply, if you are going to coat a tin metal on the iron or steel or the base metal, we call it as tinning. Now the process of coating the tin metal on the surface of iron. Now this is your iron. So this is your base metal and tin is your coating metal. Now tin is a noble metal. Okay. Now if it is a noble metal, it comes under cathodic protection, cathodic coating. As we are using a noble metal, it comes under cathodic coating. Therefore, it possesses a more resistance and to chemical attack. And as I said, it comes under the cathodic coating. Now, in this process, same as like galvanization, first we clean the metal and we are going to dip in the molten solution, and then again tin is applied, and again it is passed to a hot roller so that excess of tin will be squeezed out. Okay, we'll see detailedly the process. Here is surface of the base metal, that is iron sheet, is cleaned by acid pickling by dilute H2SO4 or dilute sulfuric acid. Now it is passed through a zinc chloride flux. Now this flux, what it is doing, it helps the molten metal to adhere the metal surface. The molten metal here is what? Tin. Okay, it will help this molten metal, that is tin, to adhere or the attach on the metal surface. Now then the sheet is passed through the molten tin bath and passed between the two rollers from a layer of a palm oil. Why we have to pass this sheet into our rollers? Because the excess of tin will be removed out or squeezed out. Now here, as we are using a palm oil in the hot rollers, it will be helping in protect the tin coated surface against the oxidation reaction. Now then the rollers remove the, as I said, it removes the excess of tin. Now the base metal and the coating metal, the junction is produced. So if you observe here, we are going to place a tin metal first, acid pickling, and next we are going to move from a pair of hot rollers. Now it is containing a palm oil, and then a tin plate sheet is removed. So applications, if you see, of tinning, it As it possesses a good resistance against atmospheric corrosion, tin is non-toxic and widely used for coating steel, copper, brass shields. Okay, next is containers coated with the tin are used for the foodstuff, ghee, oils, etc. There in the galvanization process, the iron which is coated with the zinc, we are not preferring or we are not used for the foodstuffs, right? Because it will be highly toxic when this zinc melts. But coming to the tinning, it will be good and packing the food materials. Now, tin copper sheets are used for the making cooking utensils and also the refrigerator equipment. So these are the references for today's session. Thank you.